Hello all. In today's lecture, we will be studying about counting-based page replacement algorithm. As the name suggests, it keeps the count of the number of references made to each page in a reference string. Basically, this is of two types. One is least frequently used page replacement algorithm, and another one is most frequently used page replacement algorithm. In case of least frequently used page replacement algorithm, page with the least number of references is replaced first. Basically, it assumes that heavily used pages will be referred again. While in case of most frequently used page replacement algorithm, it will be replacing the pages with the largest reference count. It assumes that the pages that has not been referred till now or which has been brought into the memory recently will be referred again. Let us see both the algorithm one by one. In case of least frequently used algorithm, pages with the smallest reference count is replaced first. So for the reference count, a counter variable is used, and one memory management unit is present in the system, and it increments the counter value at each time an in-memory page is referenced. The page with the smallest count is the one which will be selected for the replacement, and this algorithm is generally combined with some other page replacement algorithms such as first in first out or least recently used one. Let us see how the least frequently used page replacement algorithm works. Consider the string 0201 032123. We have 3 frames allocated. Initially, all the 3 frames will be blank. Here in the blue row, we have given the reference string. So initially, when 0th page request arrives in the system, there will be a page fault. As it was told, one counter variable will also be present. Counter variable will be corresponding to all the pages that has been referred. In this string, 4 pages, that is 0, 1, 2 and 3 has been referred. So counter variable will be corresponding to page 0, 1, 2 and 3. When page 0 is referred, at that time its counter variable has been increased by 1 because it has been referred first time and page fault has occurred. The next request comes for the page number 2. So it was not present in the memory, so it will be brought into the memory, and at that moment page fault will occur and the counter value of page 2 will be increased by 1. Then again the reference is made for the page 0. As 0 was already present in the main memory, so a page hit will occur and it is referred second time. So 0th counter will be increased to 2. Next page that is referred is 1. So 1 is not present in the memory, so it will be brought into the memory, and at this moment a page fault will occur and it will be brought into the memory. As it is referred first time, so the counter value of the page 1 will be increased by 1. Now the next page that will be referred according to the reference string is page 0. It is already present in the memory, so in the next reference a page hit will occur and the page 0 is already present in the memory and its counter will be page 0 counter will be increased by 1. So now the page 0 counter value is 3 and page 1 counter value is 1 and page 2 counter value is 1. Now the new page has arrived in the system. The references of page 3. Now page 3 will be able to replace one of the pages that is present in the memory, either 0, 2 or 1. So at this moment we will see the counter value. So page 3 might be replacing 0, but the counter value of page 0 is highest. So page 3 will not be replacing the page 0. Now the counter value of page 1 and page 2 both is 1. So 3 might be replacing 1 or 3 might be replacing the page 2. So the page 3 will be replacing the page number which has been referenced first. So according to the reference string, we can see that page 2 has been referenced first. So page 3 will be So page 3 will be replacing the page 2. As page 2 has been replaced, so its counter value is decremented, and page 3 has been referred, so its counter value has been increased here. Now the next request is of the page 2. Again we will be looking at the counter value. Page 0 has been referred 3 times, its counter value is 3. Then page 1 counter value is 1 and page 3 counter value is 1. So according to the counter value, the page that can be replaced is either page 1 or page 3. So out of page 1 and 3, which one has been referred earlier? Here in the reference string we can see that page 1 has been referred earlier. So page 2 will be replacing the page 1 and the counter value of page 1 will be decremented to 0 because now it is no more referred, it is not present in the memory, and the counter value of 2 will be incremented by 1 because it is there in the memory and it is referred only once here at present. Then the request comes for the first page. So again here we have the 3 contender for the replacement 0, 3 and 2. 0 is having the highest counter value, so it won't be competing for the replacement. Now 3 and 2 will be there available for the page replacement. So out of 2 and 3, whichever has been referred first will be replaced by the 1. So here from the so here we will be looking from 0 to 2, that which page out of 3 and 2 has been referred earlier. 2 has been referred but it has already been removed from the memory, so it will not be considered for the removal. So next page that should be removed or that has been referred is 3. So 3 will be removed from the memory and 1 will be entered into the memory. So the reference count will be like this: 0, 1, 2, and the counter value will be changing. 0 has been referred 3 times, 1 has been referred 1 time, page 2 has been referred 1 time, and page 3 its value has been removed from the memory, so it is not referred right now. Next request come for the page 2, and as the page 2 is already present in the memory, so there will be a page hit, but now it is referred second time, so its counter value will be increased. So the memory will be like this: the same pages will be in the memory, but its counter value has been increased here by 1. Next page came into the memory is 3. So for at that moment we have the 0 with the counter value 3, 1 with the counter value 1, and 2 with the counter value 2. So the page which has been referred with least number is 1, so 1 will be replaced by 3. So to calculate the total page fault, we will be counting the number of faults. So here it is 1, 2, 3, 4, 5, 6, 7. So 7 page faults are there, and total page hit is 1, 2 and 3. So total page hit is 3. So fault rate will be 7 divided by 7 plus 3, that is 0.7. That's it for today. And in the similar way, of course, one thing is left, that in the similar way the most frequently used algorithm will also work, but it will be replacing the page which will have the highest counter value. That's it for today. Thank you.